In this video, we're learning how to divide rational expressions, and if you guys haven't already done so, I encourage you to watch our video on multiplying rational expressions before you watch this video, because the concepts we learned in that video are going to show up in this one. So if you already know how to multiply rational expressions, then let's jump into example 1. So in example 1, we have these two rational expressions being divided. And first, what we need to remember is how to divide fractions. So remember, when you learned how to divide fractions, you may have learned this rule that is called keep, change, flip. And basically what it's saying is that to divide two fractions, you're going to multiply the first fraction by the reciprocal of the other fraction. So we're going to keep the first fraction as it is. So it's going to be x plus 3 times x minus 2 over x times 2x plus 1. We're going to change the division sign to a multiplication sign, and we want to flip this second fraction, so we're going to multiply by the reciprocal. So we're going to have x squared times x minus 5 on the top, and our numerator is going to be the denominator now. So we're going to have x plus 3 times x minus 5 on the bottom. And now our two fractions are already factored, which is nice. So that's normally the first step of these problems, is that you want to completely factor the numerator and denominator of each fraction. But because everything is already factored, what we want to do is reduce any fraction if possible and cross-reduce. So what I'm going to do first is reduce the right fraction. So we have an x minus 5 and an x minus 5 as a factor on the top and bottom. And remember, you can cross out common factors on the top and bottom of a fraction because they just simplify to 1. So we're just going to cross them out. And now we want to see if we can cross-reduce anything. So remember, that means we want to see if we can cancel out anything in the numerator of one fraction and the denominator of the other fraction. So we can cross out the x plus 3 in the top of our left fraction and the x plus 3 in the bottom of our right fraction. And we're going to be able to cross out something else, but let me write it, what we have so far, a little bit differently so we understand what we're crossing out. So now in our first fraction, we are just left with an x minus 2 on top. We're left with an x times 2x plus 1 on the bottom. And in our second fraction, we're just left with this x squared on the top, which I'm going to write as x times itself. So x times x, we're just left with a 1 on the bottom. And now you may notice that we can cross out an x on the bottom of our left fraction and an x on the top of our right fraction, because that is a common factor. And now we're just going to multiply straight across. So we're going to have x times x minus 2 on the top. And on the bottom, all we have is this 2x plus 1. And we just want to leave our answer in factored form so we don't have to do anything else. So we get x times x minus 2 over 2x plus 1 as our final answer. Let's go over some examples where our initial fractions are not factored. So in example 2, we have these two fractions being divided, but they are not factored. So what I'm going to do first is keep, change, flip, and then I'm going to factor both fractions. So I'm going to keep the first fraction as it is. So I'm just going to copy it down over here. I'm going to change my division sign to a multiplication sign, and I'm going to flip the second fraction upside down. And now what we want to do is factor the numerator and denominator of each fraction. So down here on the left, let's factor the numerator of the left fraction. So we need to think of two numbers that multiply to -6 that add to -5. And if you take a second and think about that, we should get x minus 6 times x plus 1, because -6 times 1 is -6, and -6 plus 1 is -5. And now I'm going to factor the denominator. So we have 5x plus 15. So we just want to pull out any common factor between 5x and 15. And 5x and 15 are both divisible by 5, so we're going to take that out. If we take a 5 out of a 5x, we're left with x. And if we divide 15 by 5, we're left with a 3. So we get 5 times x plus 3. And now we need to factor the second fraction. So on the top of our second fraction, we have 7x plus 21. So again, we just want to take out what they have in common, which is a 7. And we're going to be left with an x plus 3. And on the bottom, we need to think of two numbers that multiply to -4 that add to -3. And if you take a second and think about that, we should get -4 and +1. So we have x minus 4 times x plus 1. And now we want to see if we can reduce anything. And we can't reduce anything within the same fraction, but we can cross-reduce. So we can cross-reduce the x plus 1 in the top left fraction and the x plus 1 in the bottom of our right fraction. And we can cross-reduce the x plus 3 in the bottom of our left fraction and the top of our right fraction. And we can't reduce anything else, so we're just going to multiply straight across. On the top, we're left with a 7 times x minus 6. On the bottom, we are left with a 5 times x minus 4. And we're just going to leave it in factored form. So this is our final answer. Let's go through one more example. So for this last example, I encourage you guys to pause the video and try it on your own. And then you can unpause the video and watch me work through it to make sure that you've solved it correctly. So let's start with keep, change, flip. So we're going to keep the first fraction as is. We're not going to change that one at all. So we have 3x squared plus 24x on the bottom. Change our division sign to multiplication. And we're going to flip this second fraction upside down. So our numerator is now x squared plus 6x minus 16. And our denominator becomes 2x cubed minus 8x squared minus 42x. And now we want to factor the numerator and denominator of each fraction. So I'll do that over here on the left. So for the numerator of our left fraction, we have 4x cubed minus 36x. So we want to see if we could first pull out anything those two terms have in common. And they have a 4x in common. If I take a 4x out, I'm going to be left with x squared minus 9. And we're going to do a similar thing in the denominator. So we have 3x squared plus 24x. So we want to see if we could pull out anything that they have in common. They have a common factor of 3x, and if we take a 3x out, we're going to be left with x plus 8. And now we want to factor the second fraction. So on the top, we have x squared plus 6x minus 16. So take a second and think about what we can factor that into. We need two numbers that multiply to negative 16 and add to positive 6. And if you think about it, we should get positive 8 and negative 2. So we get x plus 8 times x minus 2. And for the denominator, we have 2x cubed minus 8x squared minus 42x. So we want to start by seeing if we could pull out anything that these three terms have in common. And they have a 2x in common. If we take a 2x out, we're going to be left with x squared minus 4x minus 21. And now we can still factor the numerator of the left fraction and the denominator of the right fraction. So we're going to go ahead and do that over here. So we have this 4x, and then we have to see if we remember how to factor x squared minus 9, which is called the difference of two squares, because x squared is a perfect squared and 9 is a perfect square. So we're going to take the square root of the first term, so the square root of x squared, which is x, and we are going to put that in the first spot of each parentheses. The square root of the second term is 3, so we're going to put that in the second spot of each parentheses, put a plus in one and a minus in the other. So we get 4x times x plus 3 times x minus 3 as the fully factored version of the left numerator. And then the left denominator is fully factored, so we're just going to leave it as is. And the numerator of the right fraction is fully factored, so we'll leave it as is. And then for the denominator of the right fraction, we have this 2x on the outside, and now we want to factor x squared minus 4x minus 21. So we need two numbers that multiply to negative 21 and add to negative 4. Take a second and think about that. And we should get negative 7 and positive 3. So we get x minus 3, x minus 7 and x plus 3. And now we want to see if we can cancel and cross-reduce. So let's see if we can cancel anything. So in this left fraction, we have an x on the top and bottom, so we can cross those out. I'm going to do this in a different color so it's easier to see. So we can cross out the x's on the top and bottom of that fraction. And we can't cancel anything else within each fraction, but we can cross-reduce. So we can cross-reduce the x plus 3 on the top of the left fraction and the bottom of the right fraction, and we can cross-reduce the x plus 8 on the top of the right fraction and the bottom of the left fraction. And we can actually cross-reduce this 4 and this 2 because they have a common factor of 2. So if I divide 2 by itself, it just becomes 1, so I'm going to cross that out. But if I divide 4 by 2, it becomes 2. So this is going to become a 2. And now we're going to write what we're left with. So on the top, we have this 2 times x minus 3 times the x minus 2 from the right fraction On the bottom, we still have this 3 from the left fraction. We have an x, we have an x from the 2x, and we have an x minus 7. And I'll just double check that we can't cross out anything else, and we cannot, so we're finished. So we get 2 times the quantity of x minus 3 times the quantity of x minus 2 over 3x times the quantity of x minus 7 as our final answer. So hopefully this video helped you guys understand how to divide rational expressions. If you want more practice with similar problems like this, check out the link in our description for a free practice worksheet.